Considering you got the 70s on all three tests. That doesn't mean your grade is gonna be better.
No, but he said that if I get an 88, then he'd bounce it up to a 90 because the math department isn't allowed to do extra credit. I'm like, really? I'm not a test taker.
Hold on. Did you just say the math department is not allowed to do extra credit?
Yeah.
Isn't Doug Gardner and hold on, isn't Doug
He's head of the math department.
yeah, and he gave us tons of extra credit. Like a lot.
You weren't there when I talked to him. No, our teacher was like, yeah, we're not allowed to do that. We're not allowed to give you extra
Okay,
credit.
but John,
No, Mark Otto.
He's an elementary school principal.
You guys got extra credit?
yeah, but and
Yeah,
the
so
head of
much
the math
extra
department was teaching our class.
That's crazy. Bro.
I had a chance to get extra credit. It was like 5 points. That's the only chance we had. Wait, no, we had a
What is
chance to
this?
get
Wait,
10
what
points.
class was it? Can I look at this?
Math
I'm looking at
one.
your keys. What is this? Is it boba? What thing? The lid?
Yeah.
What's in the bottom? Is it boba?
Sorry.
Guys, you know what I'm gonna do when I get home? I'm gonna take a nap. That's what's gonna happen.
I'm gonna go to bed when I get home because I don't get home till 7 from work. I'm here.
I get off at 9:30. You guys should come to my Starbucks.
I don't go to Starbucks.
Well, I work there, so.
Okay.
Don't be scared.
What'd you get on this?
I got
Don't
an
be scared.
extra,
You
bro.
said it was bad.
Yeah, I got.
It wasn't bad. The last question was bad because I didn't know how to solve it.
I
What
got
was the
this.
last question? I
This
don't remember.
one.
Oh, that's
It was like the A sub-zero
It's a
to
trick.
the
this
K.
is just 1,000.
No,
I might have left it in my office, but I'll
I
get it
got
after
fun.
class
that
for
one
sure.
right, and I got.
And it didn't give me, I feel like it didn't give me enough information to be able to solve it. So.
But then you just need
It was something like caffeine and it was a
I know. I saw
half-life.
that when we were taking it. I was just like,
Oh.
Yeah.
Did he do that?
I don't think so. Yeah.
Oh, then you just divide by 2. You said
That's, but that's not.
Oh, for doubling or half?
I don't remember.
Because I don't think we did one on.
are you guys on like exponential regression right now?
No.
No.
Oh, no, but there was a problem. No, we did exponential regression.
That's what we just started yesterday.
Do you have your test places? Or
It's next week. I have my next test and my final both for next week.
That's rough.
that's what we were gonna do.
Yeah.
And then we were like, no.
For today by 36.
I think I did actually.
7 this week.
You
7
said you
this
were
month.
gonna do an exponential regression.
We didn't do an exponential regression.
I mean, for the test.
The world
We did it.
record is
We did do exponential regression.
Not for the test.
Okay, great, that's what I was saying.
Oh.
My bad. Yeah, I don't know. The only thing I see is doubling. That's crazy, bro. So that's weird.
I have multiple.
Well, I feel like since I love hockey so much that I will.
All right.
If I
Are
had to
there
go,
any questions before we get started?
I've never had to see another coffee stand in my life.
So today's our last official lecture. And then, right, just a quick recap, so don't forget extra credit. So extra credit, I would say it needs to be in, I think grades are due like that Monday. Sorry, I don't have the calendar. So whatever like Sunday night is, 11:59, I will accept next Sunday. Sorry, I was trying to, I think it's December 9th, 10th. So you can just email it to me. I don't have it made as an assignment. It should be a column though in Blackboard, so if you've given me extra credit and it's not on there, let me know because it should be reflected. Do you else have questions over there?
No.
Okay, because you're really chatty, so no one else can hear anything. All right, so looking at the calendar, so that's Sunday, December 10th, so 11:59, so that's going to be the deadline to submit any extra credit. And so most people are doing pretty well on their labs, but just make sure that you finish up any missing assignments. So hopefully everybody did the physical lab because I'm not planning on being in lab next week. So if you are behind and need to make something up, you need to email me ASAP so we can arrange that. And so like we said, Monday we'll do review, and then that leaves us with Wednesday as our final. And hopefully everybody did lab checkout / final today, so if you missed that, then again you should be emailing me as ASAP to make that up. All right, other questions before we begin? Comments? So just keep checking your grades. I think I'm caught up on grading, actually, in this class, minus the papers that have been handed. Obviously, I haven't graded the lab finals, but otherwise, everything should be set. So check your grades. I tried to hand everything back to you right now, so you should have all your papers. So if something is wrong in the grade book, just let me know ASAP so I can fix it as I start doing the final grades. All right, so back to this classifying salts as acidic, basic, or neutral. And so we left off with this calcium nitrate. And so we're still going over this first scenario of how do we know we have neutral ones. And so let's warm up with KBr. So what was our analysis? So take a minute or so to look over what we were doing, right? So we were trying to figure out what the corresponding base was of our anion, what base it came from, and then what acid our anion came from, and then whether those were strong bases and acids. And so looking at this, so right, we were reading over, so we said, is the salt cation a counter ion of a strong base? So looking at potassium bromide, what base does potassium come from? So what's the base that contains potassium? So what do we think? So look back to Monday's examples, right? We were just picking basically the hydroxide base form. So what does potassium come from? Yeah, potassium hydroxide. And so this one is a strong base. So we can write full dissociation. And so since it comes from a strong base, that means that our potassium is neutral. So now repeat that for bromine, except now what acid does bromine come from? What's it related to?
How do we know that?
So usually you just try to like add a proton to it unless it's something, you know, funny, like we'll see the amines. Because the most basic definition, right, of an acid or a base, so we said a base usually makes hydroxide. So you're like, what base? You know, how can I add hydroxide to that metal to make a base? And then with the other one, we're trying to add like a proton to it to make it an acid ideally. Wait, what did you say? Yeah, so then it would be, right, HBr, so hydrobromic acid. And then was hydrobromic, is that a strong acid, weak acid? And remember, you can look back at this chart to help you. Yeah. Oh, I totally forgot. I didn't have, 0 times. After, when we take the quiz, I'll print out a copy. I have not stepped foot in my office today, basically. So I'll give you a copy of this while you're quizzing. But looking at this, so is it a strong acid, weak acid? So strong, good. And so right then we know it has complete dissociation. So right, we can put strong. And so if this is a strong acid, we're saying, right, again, the bromine can't reform, so it's not going to make hydrobromic acid in solution. So bromine is neutral, so overall neutral. All right, so that was the neutral case. So now let's take a look at the next cases. So we'll go through the word salad again and then practice the analysis. So now it says, okay, if the salt cation is the counter ion of a strong base, so we still have our strong base scenario, but then it says the anion is the conjugate base of a weak acid. So now we're saying, right, our anion, so basically, right, B minus here, that because it's in some sort of equilibrium, then it actually can reform, is what this is saying. So therefore, this anion, since it can reform our acid, and it'll make hydroxide, so then it falls under the definition of a base. Like I said, we'll go through the analysis so it makes sense. So let's look at this with sodium fluoride. And so look back at your notes if you don't remember. Oh, So what base does sodium come from? So what base is related to sodium? What do we remember? So you could look back, because we did the analysis earlier, right, with sodium chloride. So what were our conclusions then with the sodium? What base did it come from? So sodium hydroxide. So, right, and this is where it kind of should feel a little repetitive, and then you kind of get the hang of it. So, okay, sodium, we already said that was from sodium hydroxide. And a recap, right, strong base, fully disassociated. And so just like we said before, that makes sodium neutral. So sodium, right, we're getting the picture, it's always a neutral salt. But now let's look at fluoride. So what acid is fluoride related to? Yeah, HF. And so what do we know about HF? Is it a strong acid, weak acid? Yeah, so I heard somebody say weak. We can go back to this chart here. So this one, right, it does disassociate. We can look at, where's our pKa chart? We can look at our pKa chart as well. So anything with our pKa here. So we know it's weak. And so we want to write what's going to happen. So it can disassociate. So let's first write it out. So plus H2O. So then we form acid plus fluoride in solution. But then we're saying if it has this equilibrium, that means our fluoride in the presence of water and we'll draw this out. So put in our electrons. So we have fluoride here, and so now it can attack our proton. So it's reforming HF. And so then in solution, we remake our HF with water. And then we form hydroxide now. And so this shows us that fluoride is then a base, right? Because we said by our definition, anything that forms hydroxide is a base. And now we're explaining why fluoride is a base here. So then we can say that fluoride is basic. So anytime we see this fluoride salt, we should know it's basic. And then we had a neutral cation. And so neutral versus basic means that it's overall basic. Does that make sense for sodium fluoride, why we said this is a basic salt? Questions?
Use that one more time.
Oh, any questions why sodium fluoride is a basic salt?
The thing before it. Why it's basic.
Yeah, why?
You say it one more time.
Sorry, I asked any questions why sodium fluoride is a basic salt?
Yeah.
What makes it basic?
So what makes it basic is the fact that, so right, if you do the analysis, so we established sodium was neutral, right, because it came from the strong base. So then that left us with fluoride, and we said, okay, well, it's weak here. And so I showed the mechanism. And so that's the other key. So write that down if you haven't. So right, anions are either basic or they're neutral, and then the cation is usually acidic or neutral. So those are what you're trying to figure out. And then, okay, well, we figured out our cation was neutral, so then we're trying to figure out is our anion basic or neutral. And because it's the conjugate base of our weak acid, it's considered basic.
Wait, so you said anions were either basic or neutral?
Yes. Either acidic or neutral. So those are like your two options. So you usually don't have a basic cation. So that was going back to like the different strengths of acids and bases. And so this means, right, any sort of fluoride salt would be basic, right, unless the cation is acidic. So what I mean by that is like lithium fluoride would be basic because lithium is neutral. It comes from lithium hydroxide. Potassium fluoride, right, same issue. So it comes from potassium hydroxide. So that would be basic. So yeah, rubidium fluoride, etc. So all those are basic salts. So I'll put basic salts due to the fluoride.
So was it the molality chart that we looked at? You flashed to a different chart looking at some values for it to help tell whether it was strong or weak. Because, I mean, it was kind of in the middle of the chart.
So
We went to a different chart.
this chart, so there's two different charts. So there's either this chart, which I'll get to you while you're quizzing, and then the other chart that I flashed was this pKa constants. And so anything with like these Kas, so I'm just looking at like some sort of equilibrium. We're not seeing some like extreme value that would show us it's all the way to the right or the left. But all these are weak acids, right? So that's the key to this chart is it's a chart of all weak acids. Yeah. So let's try another analysis. And so now let's try, so they gave us calcium acetate. So let's go through that one. So CH3COO is our acetate. So I'll put in parentheses acetate. So let's start with our calcium. And so what do we know about calcium? Acidic, basic, neutral. So neutral, right? And so we know that since it comes from calcium hydroxide. And so, right, you're seeing a pattern with all these hydroxides that they fully disassociate. And so that makes calcium neutral. Okay, so that was the first part of that word salad where it was talking about coming from a strong base. But then what do we know about acetate? What acid does it come from? We've been working with acetate a lot. So what acid is acetic acid related to? So what lab did we just do where we did some titrating? Maybe you saw acetate in there. What'd you say? Well, sodium acetate, that was the product, right? So remember, so we kind of, where can we write this? So this is an aside. So, right, we did make sodium acetate. So remember, we did some neutralization reaction in our titration. We made sodium acetate. And so what was the acid, though, that we titrated? Vinegar. So, right, acetate is acetic acid, which is just vinegar. I wrote that funky. Sorry. CH3COOH, so that's a little more clear. So, yes, so this is acetic acid. So, okay, acetate, right, comes from acetic acid. And then we did our titration. And so then, what do we remember about acetic acid? Was it strong? Is it weak? Weak. So it's a weak acid. So let's write out what acetate is doing in solution. So now if we just have acetate, and it might, I don't know what's better for y'all, because I think it's better to show this structure. Otherwise, this just looks like a salad of letters. So, right, we have our acetate. So I'll write it out again. So acetate. And don't forget, it can be written, right, in several different forms. So that also makes it confusing to identify. So acetate in the presence of water. And so, right, we have this oxygen with all these electrons on there. And so now I can reform our acetic acid. So drawing the action from the electrons again, it plucks off a little hydrogen from water. And so then we reform our acetic acid. And so, right, rewrite this again. So this is just our acetic acid, right? That's just this structure, CH3COOH. And then we make hydroxide. So now just from our definition of acids and bases, since it makes hydroxide in solution, acetate itself is our base, or is basic. So from acetic, so weak, and then neutral cation, like we established, plus a basic anion gives us an overall basic salt for our calcium acetate. Does that make sense for this one? So now let's look at this potassium, and now that's nitrite. So we don't often see this. And so let's just do the same analysis. So we can start with potassium. Again, maybe we can move a little faster. So what do we remember about potassium? Acidic, basic, neutral? So neutral, exactly. So remind yourself it came from KOH, so that was strong. And so that means that potassium is neutral. Excellent. So now let's look at nitrite. And so do we remember what acid it makes? You can always flip back. See, this one is actually helpful, if you can spot it on there. watch so nitrous, right? Yeah. So these are the weird ones with the naming, so just watch. So, right, HNO3 was nitric, so that's a strong acid. But then nitrous, with less oxygens, is a weak one. And so we can tell that from our pKa, and of course they also showed us the equilibrium. And so now we can tell right away that if this is a weak acid, right, that's going to make our nitrite basic. But let's still go through the mechanism just so it's clear. And so now nitrite plus water. So again, all the electrons are here. So let's draw that. Let's draw this better. I didn't draw the Lewis dot structure very well. Let's see, how many electrons do we have? So we should have 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is, right, nitrite here. And so this oxygen that's carrying the negative charge, again, you could draw resonance structures. Is that clear to people? So we could like draw it right where the oxygen has a single bond on this side, charge on this side, doesn't matter. But then once you actually draw the mechanism, again, it wouldn't matter which oxygen we attack from. And then just showing, okay, now we're going to reform our HNO2 then, and then we make hydroxide, so that shows us that our nitrite is basic. So then, again, neutral cation plus basic anion gives us overall basic salt. And so, just like before, any other like lithium nitrite salts, all those would also be basic. All right, so let's look at our next scenario. And so you'll notice there's a limited number of these, which kind of works out in your favor. So let's read the word salad. So it says, if the salt cation is the conjugate acid of a weak base, okay, so right, our acid then has to come from a weak base, and the anion is the conjugate base of a strong acid, okay, so the anion is neutral, so we don't care about that. So then the cation is acidic, the anion is neutral, and so we get an overall acidic solution. And so kind of the trick, though, is, well, what bases do we even know? Or how, right? So, like, what bases? We only have so many options is what I'm getting at. Because all our other bases, right, all our hydroxide bases are going to be strong. And so the only thing left is going to be what I call these like amines. And so let's look at the structure you're looking for. So right, NH4Cl, let's go through the analysis. Ammonium chloride. And so actually let's start with chloride. So what acid does chloride come from? You can also give me acidic, basic, neutral for chloride. So it's come from our hydrochloric acid. And so that follows what our word salad said. So right, strong acid. So our chloride is neutral, our anion is neutral. Now and this is a weird one now. So now we're like, what base does ammonium come from? And so now we can't just add a hydroxide to it, right? We have to maybe remove a proton. Ammonia, so good. And so now we're kind of seeing too all the possible scenarios, right? So basically, and again, for our purposes, you won't have too many options. So either it has to be ammonia or some sort of like ammonium derivative. And for example, so let's skip ahead to this practice problem. And so this practice problem confuses people every year. But let's break down what the heck this is. So we have this weird CH3, NH3. Okay, well this looks like a word salad mess for a second. But we have nitrate. Okay, well we know nitrate. We know what that is. That's cool. But what the heck is this structure? CH3, NH3. Does it remind you of something? So kind of separate it out. And then by charge, it has to have a plus sign on it because nitrate is negative. But what does this look like? What does it remind you of? What does this look like? It has NH3. What does that kind of look like that we were just talking about? So draw out the structure too. So that might help. So draw it out. So this is just a methyl group. So CH3, so that would look like that. And then it has 3 hydrogens attached to it. So what does that look like? Just remind you of something. What was our example? We were looking at ammonium chloride. So what if you draw out this structure of ammonium? What does that look like? So if we draw out ammonium, right, NH4 plus, so do these look kind of similar? And so that's really the only types of compounds you'll see. So let's go through the ammonium one, so ammonia to ammonium, but then we'll revisit kind of what structures are going to be the only ones really. So if we go back to this ammonium chloride, so we said, right, it was from ammonia, so that was good. So we already knew that this was, right, a weak base. And so if it's weak, again, it's going to have equilibrium. Oh, we don't have ammonium. Those are acids. So now let's draw out what happens in solution with our ammonium. So we have, right, our NH4, so draw it out. So now, right, it has a plus sign. And we have water. So if this has the plus charge, right, it's going to be acting as our acid, and that makes sense, right? It's our conjugate acid from our ammonia base. And so now, in this case, the water is going to do the attacking. So now water is going to take off one of these hydrogens, and then we'll reform our base, so NH3. But then we make our hydronium. So we make our acid, right, our H plus in solution. And so that's why ammonium is considered acidic then. And so what I was trying to get at with this, so this is called, this would be methylammonium, which comes from methylamine. So methylamine, we can draw this out just for clarity. So let's start with methylamine. So methylamine is this guy right here. So similar to ammonia, right, we just replaced one of the hydrogens with an R group essentially. So again, that has to take this form. But these are going to be, again, your bases that you're going to encounter. But for your purposes, you'll probably only see ammonia and ammonium, and then maybe something slightly tricky like a methyl group. But for your future information, right, it could be any other R group here. So there are tons of amines. So I'll try to show a picture of amines. So if we're looking, let's start with, so right, this is methyl ammonia. And if you guys watch Breaking Bad, this is the chemical that they steal from the big train heist. So, yeah, good luck. Or methylamine, sorry, that's its proper name. So methylamine is now a highly regulated substance. So let's first watch it be a base. So right, it's in its base form right here. So this is the base. So acid. So just like ammonia does, so it's going to pluck off a hydrogen, right? So it still has a lone pair, just like ammonia. So this should look just like ammonia. And then now, right, those electrons made a new bond. So there's our H, there's our methyl group of CH3, and then our remaining two hydrogens. So now methyl, ammonium, plus hydroxide. So there's the first step. Now we can see how the methyl ammonium also acts as an acid. So right, same thing that happens with our ammonium that we just saw. So let's watch that again. Right, so it doesn't matter that there's a methyl group on there. And I'm just redrawing the methyl group up there because I think it looks prettier. So now, right, it's our methylammonium. We said it's going to be acidic, but let's check that out. And so just like we saw with the ammonium, right, electrons come, they're going to attack this plus charged species anyway, so that's better, reforming our methylamine again. and then now we make our acid. So once again, showing how these ammonium derivative salts are acidic. So acidic, so that makes our methylammonium acidic as well. And so this is just a list of other amines. So you could even have them like trimethylamine. So notice, right, there's no hydrogens on it, all methyl groups, but then it can still pick up a hydrogen, right, and become trimethylammonium, just like all the other amines. So now I'm putting this out there again as extra information, kind of for your information. So if you go on to OChem, you would know where this is kind of derived from. But for our purposes, what you'll see in Gen Chem will be limited to, again, ammonium and then maybe a methyl derivative. But does that make sense? So then if we scroll back up to this little scenario, right? Well, they only gave one example, but let's try to think about that. Well, can we think of any other conjugate acids of weak bases, really, that we've worked with? You know, we have very few polyatomic cations to start off with, so that's kind of an issue, right? All our other group 1, group 2s, those are related to our hydroxides, so again, it's really just the amines that are going to be relevant. So I'll put here amines, so that's what we're looking for. All right. And let's look at, so then this last little one, so this is a interesting scenario. So it's a little different. So now they use this term highly charged metal ion. And so we won't see this too much in this class, but usually we're looking for a metal like aluminum 3+. And then, so notice the anion is just neutral again, so conjugate base of a strong acid. And so this is, again, special scenario, so I would write here, so special for metals, and again, mainly aluminum, probably like gallium as well. So probably looking for like 3+ or greater oxidation states. So you could also theoretically have like probably tungsten in the 6+ oxidation state would be considered acidic, but for our purposes, we probably won't look too much at this, but this is at least good to know for your future. Oh, question? It'll probably show up in some form, but like I was saying, so I probably won't ask you about the metal ones, but we'll, I would expect to see acetate or fluoride, like trying to identify some of those, and probably, ammonium or identifying neutral ones. So yeah, it'll be on there, but I won't do really hard stuff. And so with that note of what I will do and not do, so we have the last scenario, which again I want us to be aware of, but you would have to do calculations, and we're just not going to go there. And so the last scenario that we didn't cover is, well, what happens if, and so if we read the word salad, so if the salt cation is the conjugate acid of a weak base, so that would mean, right, our salt is acidic, and then the anion is a conjugate base of a weak acid. Okay, well that means our anion is basic. So then, well, how do you know what it is? If your salt is acidic, your anion is basic, what's your salt? And then the caveat says, well, the pH depends on the relative strengths of the acid and the base. So again, we won't go there in our course because now we would have to look up too many constants. But basically what you would do is see, well, which one is stronger? So you compare the Ka of ammonia, because you would want to look at the Ka since it's acting as an acid. So you're seeing like how strong of an acid is it versus the Kb, which is telling us, right, how much of a base our anion is. And so in this case, so HF is a stronger acid than ammonium, so the Ka of ammonium is larger than the Kb, so then the solution is acidic. But again, this is kind of more for your information to maybe digest later in other courses, but for our purposes, this starts to get into just like a little bit too much, at least given, you know, the time we have. But just kind of for your reference, that's how you would do it. So you'd have to compare which one was stronger, and then that tells you. But all right. So, man, we're like almost out of time again. So let's go through these, or take a couple of minutes. I know we're running out or over time, but let's at least go through these really quick: acidic, basic, or neutral. And then we'll do our quiz. So let's try to go over these. So what do we think about strontium chloride? Acidic, basic, neutral? So neutral, right? So strontium came from strontium hydroxide, so that's a strong base. HCl, so that's where chlorine came from. So everything ended up being neutral. What about aluminum bromide? So that was that special one at the end. So what do we say? Acidic, basic, or neutral? What was the last thing we said about metals? And then metals were either acidic or neutral. So what do we think aluminum bromide is? Acidic, so good. So right, aluminum. This is one of those highly charged species. So bromine, right, comes from HBr, so that's a strong acid, so bromine's neutral. But yes, the aluminum would make it acidic. So again, for our purposes, I'd only give you maybe aluminum if I was to test you on the metals, but I try to stay away from those. And then, so we went over this one. So what was it again? Remind me. What do we say about this? So this would be methyl ammonium nitrate. So acidic, so right, we had established our nitrate was neutral from nitric acid, but this was just like our ammonia, so that was acidic for our salt. Good. What about this one? Did we recognize what this molecule was? Or what acid it's from? So you could either give me the salt or the acid. We might need to look at this little chart over here. So what is it? Flip back over. So what is that? CHO2. What does it match with? Formic acid. Excellent. So formic acid is on our weak sheet. And so this is formate then. So then is it acidic, basic, or neutral? This sodium formate. Basic, excellent. So basic, right, so just go back to, okay, it's an anion, so it has to be basic or neutral, but then it came from our weak acid, formic acid, so yes, basic. And then, and then this last one, so this one, right, this would not be on our exam, because I would not ask you to do that, you would have to compare too much, so not relevant for us, but it would be acidic, again, but we'd have to look at our constants. All right, I think we're out of time. So the last thing that we didn't go over is just the titrations. But for this, so we can do review on Monday, but this is really, right, your stoichiometry. And so ask for help if you were struggling with the acid-base lab. But right, it's really just stoichiometry problems. So setting up our neutralization reactions, are they 1 to 1? Is it 1 to 3, 1 to 2? And then of course doing the math. But we'll save the practice, I guess, for Monday, given the time. All right, I'll hand out the quiz, and then you can take your 10-minute break if you need it. And then, like I said, ask for help. Now's a good time to get all your questions answered. Finish up those labs, all those good things.
You have to talk. You don't have to talk. There's this lady on TikTok that literally looks like mustard, and she dips everything in mustard. She dipped a pecan in mustard. She'll be on a pecan. It's a pecan. It's a pecan. It's a. Don't ever say that again. It's a pecan.